go to the second part, symmetry of graphs. So as you can see, symmetry of graphs of relations can have two different types. So we have two different types of symmetry. What are the two different types? The first type here is the line symmetry. So the line symmetry can folded along a line so that the two have matched exactly. So if you have a piece of paper, okay, and if you need to fold this paper from the middle, so for sure this side here on the right will be equal to the same side on the left. Okay, so this is what it can be. Also, if you same thing fold the papers, okay, like this one, so for sure this side above will equal the same side in below. So this is the line symmetry. Both of them are same, so that's why we told them as line symmetry. Now then the second one, point symmetry. What's the point symmetry? Point symmetry can be rotated 180 with respect to a point and appear unchanged. Means if you look to the graph, okay, if you look to the graph, so now let's say this point here is 1 and example 2. So the point here, the coordinate for this one is 1 and 2. Now if I told you the graph here is -1 and here is -2, so and the point is somewhere here, so what is the coordinate for that point? You will tell me the coordinate for that point is -1 and -2. If you look now to this point here and this point here, they are similar, they have the same values except with the change sign. So as you can see, so the first point here 1 and 2 are positive, so symmetry, point symmetry, it has same value but with different signs. So as you can see, -1 and -2. So it was 1 and 2, so the symmetry, point symmetry, it should be -1 and -2. Okay, so this is the point symmetry. Now if you look to this table here, this table or this graph represent everything. Okay, first thing, if you look here, the first one is the model. As you can see, when you have symmetry over the x-axis, so if we read here, the graph of relation symmetric with respect, okay, let me put it here, so if it should be with respect to the x-axis and the x will stay positive, the y will be negative. So this is what you can see in this situation. Okay, then we have in the second situation, which is the respect to the y-axis. So if you can see, respect to the y-axis, and here the x should be negative and the y should be positive. So this is how you can differentiate between the symmetry respect to the x or symmetry respect to the y. Now the last one is the respect to the point or line symmetry. Okay, let me put it here. So the symmetry with respect to the origin. Or what's the meaning of origin? Or respect to origin. So origin means this one here. So this one is the origin, respect to the origin, respect to 0 and 0. Okay, now and you know, as I explained here, the numbers will be same except the sign will be different. So that's what you can see, -x and -y. Okay, now let's go down also for the odd and even function. How we can know is this function is even or this function is odd? Let's read here. Functions that are symmetric with respect to the y-axis, okay, respect to the y-axis, called even function. Respect to the y-axis means which situation? It's this one here. So this one should be an even function. Okay, and if you look here, functions that are symmetric with respect to the origin called function odd function. So as you can see, this one should be respect to the origin, so means we are talking about this one here. So this function should be odd function. Maybe some of you will ask me, teacher, okay, how about the respect to the x? Let's keep it later and we will see what's the respect will give us. Okay, now let's take some examples. Okay, now example 5, test for symmetry. Read the question first. Always, girls or boys that I teach them, always read the question before you start solving, because if you didn't read the question, you will not know what the question asks from you. Here, use the graph of each equation to test for symmetry with respect to the x-axis, y-axis, and the origin. So we need to test this graph is symmetrical respect to what? X or y or origin. Support the answer numerically, then confirm algebraically. Okay. First, if you look to the graph here, the graph is just from your eyes, graphically. So from your eyes, if you look here to the graph is respect to the x-axis. Why it's respect to the x-axis? We know that if it's respect to the x-axis, every x point should has negative y point. Okay, so example, if you look to the this point here, okay, what's the coordinate for this one? This one should be 1 and this one should be 2. So 1 and 2. Okay, now look to this point here, the opposite point. Sorry, if you look to the opposite point, okay, so the opposite point is -1, okay, and sorry, not -1, it should be 2. Okay, sorry, let me write the coordinate for you. Sorry. Okay, so the first point here, let me write it in the blue. This one, 2 and 1, right? Now, if you look to the point here below, it should have same x2, but the y is what? Is -1. So do you see now the coordinate for this and this? X did not change, but the y is changed. It was positive and become negative. So this is how we can confirm it graphically. How we can support it numerically? Numerically, just make tables. Make table x and y. Okay, x and y, and just same thing. So as you can see, the point here is 2. The point here is equal. Example, let's say. Sorry, the point here, the x coordinate, this is 2, this is 4, 5, 6, 7. So this one here is, the coordinate is 6, and on the y-axis is 2. So for sure, if this one 6 and 2, the point here down, okay, the point here down, for sure it will be 6 and -2. So if we make the table, the first point here, it will be 2 and 1, okay, and also the second point in the red one, okay, which is the opposite to that point, it's 2 and -1. Same thing if you look here to the 6 and 2, 6 and 2, okay, same thing for 6 and -2, okay. And if we complete doing the table, this is how we can support our questions numerically. Okay, I hope you understand this. Let's look to this example in the second one. Maybe you understand more. Okay, look to this question. X equal 4. Now, if you look to the question here, oh sorry, I forget to support this one algebraically, because the question said support the answer numerically and support it algebraically. So now let me do this one here algebraically. Okay, algebraically is related to the even and odd, and we know that algebraically, we know that if the function is even function, so that's mean respect to y-axis. If the function is odd, so that means it's respect to the origin. Okay, and look here to this question. Okay, here, let's support our answer algebraically. First thing, algebraically means you need to we have the equation. Okay, so we need to use the equation. Now, if you look to the equation, okay, we know that the question from what we get is -y. So we have to replace every y with negative and a negative number. So now, let's write this one, x minus from the question. Okay, then now y is equal what here is negative. So now keep the minus, but instead of y, -y. So all of that square equal 1. So now if I ask you to simplify this one, y -y square, can I have here any negative answer? Because this one is square. I can't have any negative answer because the square will remove any negative number, so it will turn it to positive thing. Okay, so the question will be going back to the origin one, which is this one. So when you have something like this, so we can, when the question back to the itself, so we can call this one as symmetry. Okay, is symmetric. Okay, with respect to x-axis. Okay, if the question did not change after you apply the negative sign for the y, or if you apply the negative sign to the x, so it's respect to the x-axis. Okay, so this is how can I support graphically, algebraically. So again, to support it algebraically, you have to take the equation and after you find the coordinates, the origin, so how we can find it, you need to memorize it from this table. So as you can see, when we talk about x-axis, so it should be this one. When respect to the y-axis, should be this one. Origin should be this one. Okay, so always memorize this. Now the second question is this one here. So how we can analyze this graphically? So if you look to the points here, to this graph, what do you think is this graph, okay, should be symmetrical on what? Is it should be symmetrical or y? No. In x, it cannot be happen. So this one for sure it will be origin. Why? Because if you look to the point here, example, so the point here should be example 2, and here should be 2. If you look to the point on the opposite side, this one should be also -2, and this one -2. So this point 2 and 2, and this point here is -2, -2. So they are same point with different signs. So for sure it will be -x and -y. So this is how we can analyze it graphically. How can I support it numerically? You have to make a table as I told you, and now pick random number on the graph. So for example, if I picked here 2 and 2, and on the other side I picked -2 and -2. Okay, and even if you picked any point in the graph, example, let's say I will pick a random point here. So I will just pick any random point here. Okay, and this one here. So at this point will be 4 and 1. So for sure the other point should be -4 and 1. So it should be here. So this one should be -4 and 1. So -4 and 1. And here also it will be 4 and 1. So this is how can I support it numerically. So as you can see, every x is repeated, okay, with a negative sign. Now how can I do this one algebraically? So algebra, as I told you, to apply this one algebraically, so you have to take the equation. Now the equation is this one, x y equal 4, x times y equal 4. Now both of them are negative, so I have to replace x and y with negative. So now let's put -x, okay, times -y equal 4. Now if you look to the question, both of them, x is negative, y is negative, and both of them are negative. So when you multiply negative with negative, okay, the question return back to itself. So as you can see, this one is back to itself, and because it's back to itself, so this one is about respect to origin. Okay, I hope you understand this. Now if you have any question, please let me know. Here the last example, how we can identify this function is even or odd. The last thing here, so to identify the question even or odd, read the question always, graph each function, analyze the graph, determine whether each function is of even, odd, or neither. Okay, confirm algebraically if odd or even, describe a symmetry of a graph of function. Okay, if you need, we are not going to graph here because it will take time from us, so I will just do it algebraically. Now to do this one algebraically, you have to replace every x with 0. So if I go back here to the table that we did here, so how we can know if it's even or odd? So you have for every x in the domain f, so you have to replace every x with negative. If the answer of the equation become positive, so this one is even. Okay, so if you add negative for every x in the question, so it will be even. When you apply negative x and the answer is negative, so this one is odd function. Okay, you see now in the example, if the question is change, everything is the question change is not become positive or negative, so this one we call it neither. Okay, now let's go to the question and examples, and let's try. So look to the first example, f of x equal x cubed minus 2x. Now let's apply negative for every x. So if I put negative for every x, so it will be negative x cubed minus 2 negative x. So now when I have negative to the power of a 3, so it's become positive or still negative? It's still negative, so that's why it's negative. Now -2 times -x, it become positive. So now if I take a negative as a common factor, so as you can see, I return back to the same question. Okay, it's same thing here, but I have what? A negative sign outside. So as you can see, because I have a negative, so this one should be odd function. Okay, now let's apply negative for this. So g of negative x equal negative x to the power of 4 plus 2. Now any number any power, if it's even number, okay, if the power is even, so the x, any negative will cancel, will be positive. If the power is odd number, so the x will still negative. That's what you can see here. The power is a 3, so when you apply the negative is still here. But here, when you the power is even, so when I apply the negative x, it become now x to the power of 4 plus 2. So now if you look to the question, okay, after we apply the negative, the question still same thing, no change when we apply the negative. So if we add negative or we didn't add the negative, still the question still same. So that's why we call this one is even, because, okay, because f of x, f of negative x, or let's say g of f negative x, okay, g of negative x, it's same as g of x. Now let's go to the last one. So you have to apply negative x for every term. Negative x, okay, negative x cube minus 0.5 negative x square minus 3 times negative x. So now, because this is odd power, so it's still negative x cube. This one is even power, so the negative will cancel, so it's still 0.5 and x square. This one negative with negative, so it becomes positive x, as you can see. Now look to the question here. Is the question after we applied the negative x, is it similar to this one? As you can see, this is negative, this is positive, this is negative, this is negative, this is negative, this is positive. So it's not same. So all the sign have changed, and if we apply a negative sign as a common factor, still the b will not be the same sign here. So this one is neither, it's not even and it's not odd function, okay, because when we apply the negative sign we didn't get anything. The question, just the whole question changed, and we didn't get any benefit from the negative. Okay, now I hope you understand this. We finished the lesson. If you have any question, please ask me. Try now to solve this question by yourself, okay, and let me know. Thank you, have a good day, bye bye.